molecular compounds. So now for the next piece. So with that being said, let's go on to the next section here, just to double check. Alright, so we have two structures here, piperidine and aniline. So piperidine is a 6-ring structure, and I would call it carbon ring, but the only thing is that the nitrogen is just snuck right in there, so I can only say 6-ring structure. And as the last piece, it's a hydrogen. Okay, that's piperidine. My picture may not be as nice as that one, but it does its job, hopefully. And aniline is now an aromatic because it has a benzene ring. So that's what that is. As you notice, whenever you see something like that and you don't see any nitrogens in it, it's just carbons, double bond, double bond, double bond, like 3 of them specifically. That's what you call benzene ring. Okay, so the benzene ring attached to, as we discussed earlier, an amide, NH2. Okay, so that's aniline. Now if we to draw the same way that we draw piperidine, this is what aniline looks like. Okay, so with that, they're asking us to now draw N-methylpiperidine. So we have now, instead of piperidine, we have N-methylpiperidine, and we have N-dimethyl-piperidine. Okay? Whoops, no, dimethyl aniline. So right off the bat, okay, you know that because these two have the same ending and these two have the same ending, is that these two structures are going to be very similar to each other. We just now notice a difference. So with this, when you go back to your nomenclature, you know that when they say methyl, or when they have a prefix, you know, of something indicating like methyl, ethyl, propyl, it means that there is going to be a chain, and the thing before that prefix, the N, for example, tells us where it's located. So because it says N, we know it's going to be on the nitrogen, meaning that the nitrogen gets rid of a hydrogen and gets replaced by what's it called? I'm losing the word for it, but a functional group. There we go. It gets replaced by a functional group. So methyl, just as a quick review, methyl looks like a functional group and just a line because it's just carbon. Ethyl looks like that and 2 lines because it's 2 bonds. Let me just make it more clear. And propyl, R3, and you kind of get the gist. It can keep going past this, butyl, you know, pentyl, and it keeps going on and on, but pretty much this is what it looks like. So now we have where it is, we have the length of it, and we know what the original structure looks like. So with that, we can actually draw what this would look like. So this is going to be a 6-carbon ring. Got to get my house tops better. Well, I call it 6-carbon, which is not it. It's just a 6 ring because nitrogen is there. And instead of this hydrogen gets kicked out. So unfortunately, he no longer makes the cut and is replaced by just like that. So it looks very similar to the picture, but now instead of actually distinguishing, saying it's an H, you just draw that line, because this line right here, this signifies that there's a CH3 bonded to it. So carbon initially bonded to the nitrogen, followed by it splitting into 3 hydrogens that it's bonded to fulfill that 4 structure. And now let's go into N-dimethyl aniline. You see dimethyl, as in di, not, you know, di. But point being is that because it's a dimethyl, that means 2. So that means you have 2 methyls attached to that N in the aniline, hence why it has NN. It tells you both of them attached to the N. And the reason why this is good, because you notice right off the bat, this nitrogen had 2 hydrogens. So now both of these hydrogens don't make the cut anymore. So now what you have is your picture is you have the benzene ring, okay, and now the nitrogen, and they just have two little sticks sticking out, because that signifies, oh, we no longer have the hydrogens, we now have CH3s in each part. Okay, so that's how you draw them. But this is now asking you to classify each of these as a primary, secondary, or tertiary amine. So primary means that nitrogen has only bonded with one carbon. So it looks like this. So primary would look like N, or actually as a picture, just to make it easier, it looks like this. A functional group, 2N, because that's what, you know, carbon, and then just 2 H's. And a functional group, you know, are going to be that carbon chain, okay? And then secondary would be, you know, same thing, but instead of it doing, just give it as much space actually. Secondary, it'd be like the functional group N, another functional group, and then H, okay? And tertiary, you probably guessed it, it's going to be N just surrounded by these functional groups. And that's all nitrogen can do, because if you notice with nitrogen, it's the fifth, it's on like the quote-unquote fifth row, but point being is that it wants to have you know, a full shell, but it already has 5 electrons, so that's why it can only take 3, because you notice that there's always going to be some electrons chilled on the outside as part of nitrogen. Okay, so this is what we're looking at for primary, secondary, and tertiary, and it's asking you for the primary, secondary, and tertiary labels for this new stuff. So N-methylpiperidine, look at it, you notice there is indeed a carbon here and a carbon here, along with the one that we discussed. So this one is going to be a tertiary amine, and here as well we know this is going to be a carbon. That's what a benzene ring is, it's always carbons, and this is going to be a carbon here, and this is going to be a carbon there. So this is also a tertiary amine. So both of these are tertiary, but for extra note, if you wanted to go back to the original piperidine and aniline, you notice here, carbon here, hydrogen. So this is actually a secondary amine, and aniline, carbon here but 2 hydrogens. This is a primary amine. Okay, so that's what we have there. So let's see now what we get for the answer. I think my picture is nicer. Just kidding. But as you see here, we have N-methylpiperidine, just a little stick sticking out. That indicates for methyl. And N-dimethyl aniline, you have that benzene ring, and then you have the N, and then just 2 sticks sticking out. That signifies the 2 CH3s bond to it. And they both say that they are tertiary, so all of this is correct. So finding whether they're primary, secondary, and tertiary is relatively easy, because we have to just count how many they're bonded with. But the important part is drawing them. You need to know the nomenclature, and you need to know how each one gives you a clue on how to fill in the rest of the picture. Okay, so with that, let's go to the next question. And let's see here. That's very strange. Sorry about that. Okay, give me a quick, let me just fill in, get back to where we were. Okay, this is correct, as we discussed. Solve for, as we discussed earlier, we want to make sure that we solved for the oxidation number first. Correct. Okay, and then I guess this is just a free review, I guess, as we're going through. This is wrong because it is not a strong acid. It is a weak acid. Use ice table. Okay. And for this question here, We discussed that this is correct, although there's ways to go about it, but just go with PV equals nRT if you're always unsure. And now, let's see here. This is the one that we just say that knowing your names as well helps, because the one that says carboxylic acid is probably most acidic, but just knowing which oxygen can actually get away hydrogen, that's usually how it works. And then we discussed already in terms of ionic compounds. And on the question we were at, we were discussing the amines. So there we are, we're back to where we were, and this is also correct. There we go. And now we're going to go on to the next question. Oh, well then, I guess that's it for today. It seems like that's all the questions that it's allowing us to solve for today. So with that, thank you again for watching this stream. Just get out of here. So thanks again, and as I said earlier, if you have any more questions, just follow the link in the description below. We'll be here solving many more questions, and hopefully we'll be able to answer any other extra questions you have. All right, thanks for watching, and my name is Fajero.